Rolling.
Okay, good. So we're doing the little check on this inverter. It's a PVI 5000 OUTD Australian version, power 1. Part number 3 Golf 04996 Sierra 0 Uniform Sierra. Serial number 624269. Okay, it's in the off condition, and we're going to just power up. Standard brief. Yes, it is. Standard power up. We'll turn on the panels. Right now the disconnect, DC disconnect is off, and it's coming on as we speak. Click. Immediately the inverter jumps into action, power on, and it goes through its process. I don't know how easy to get out of this, but we'll see what it comes up. We'll see if it comes up. Alright, it's detected a grid, 239 volts, acceptable as it says in range. It's detected a grid frequency, 49.95 Hertz in range. It's checking some insulation, 5.39 megohms. I would have normally said that's acceptable. Not sure what inside this unit says it is. Grid in range, grid in range. Couple of relays clicking on. Your green power light is now solid. Goes through a sequence of things. One of the outputs it just showed was 0 output. Inverter temperatures, that output of 6 watts is effectively nothing. Good voltage on the grid. Again, almost nothing as far as current. Okay, that V in is 348 volts, which we will measure with a meter, but that's the string voltage, which is reasonable. 10 panels at 30 something volts, open circuit. Right now, since nothing is coming out of it, we are going to assume that they're open circuit, but we will measure it. Here's the inverter's theory that everything is okay. Part number, serial number showing up. So the first thing I will do is disconnect the grid. Focus on that there. So I'm pulling the grid. So the grid disconnect. Warning, grid fail. So the inverter knows that the grid is about, and now it's gone. Warning, grid fail. I'll put back in the grid. Let the grid come back on. It's going through a process. The alarm for the grid fail had come on for a short spell, and the grid is back in range, and the alarm light is off. Inverter has done its job. It's seeing a good grid. Alright, pause Alright, we've returned to our audio and our visual, and looking at what's coming out of there. You might not be in focus that close. Alright, same thing, 230 volts, blah 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 blah, 49 Hertz. What I'm going to do is I'm going to let the inverter read the voltage. 347 volts V in. That's the inverter, 344 volts. I'm going to then read that same voltage across the pins with the meter, just to prove that the inverter is reading its stuff properly. So I'm going to read it here on one of the strings. Now, other than the polarity being wrong, 344 or 344 volts. We just read that on the inverter, and we're reading it on the meter, and I'll just go across these other two. So we got, again, 344 volts on the meter and at the inverter. Draw back so we can see the routing. That's the inverter output, sorry, the input to the inverter. to pairs of wires, in other words 2 strings. The wires behind here are not connected. Alright, that's the reading with the inverter theoretically connected. We are going to read the open circuit voltage of the strings. That is, we're going to disconnect them. I'm not going to disconnect them at the board. That's unnecessary. We will disconnect them at the disconnect and read it at the disconnect. Disconnect coming off now. Pause there till we open that.
Go again.
We're coming from the inverter, the DC input, through these 2 little tubes here, into the disconnect. And everything is wired, string 1, string 2, coming from the panels. So we just measured roughly 344 volts on both strings. So what I'm going to do is I'm going to, same meter, maybe you can see it here, I don't know. I'm going to measure this voltage again coming in. Let's see if I find it. How about him and them? Alright, we got it again at the strings. Well, it's just this, the clouds have come out again. So that's 333 volts. Again, 10 panels, over 300 volts. So you're looking at an open circuit voltage of 30 something per panel. That's 1 string. And I will measure on another string if I find it. Let's see, he looks like a good fella. Let's see what he says. Again, oh, he dropped out. 330 odd volts. That is open circuit upstream of the disconnect unit. Okay, upstream. We're going to close that switch right now to alleviate anybody's fears that we're losing something through our fuses, but we already checked it at the inverter. If it's good at the inverter, it's going to be good all through here. So at the top of our fuses, readings 334. Bottom of the same fuses. Now the sun is almost gone completely behind. 334, those are good. Other side, this is string 2. Top of fuses 328. Other end of the fuses 327. Nothing wrong, all coming through. Now we are going to connect, once we are satisfied that the voltage from the panels is 330 odd volts. If this inverter connects to the grid and starts to generate power, it will draw that voltage down. It will draw that voltage down. So what we're going to do is establish a measurement. Let me see if I put it on here. I don't know if he will stay in there. No, he probably won't.
I'll hold it.
Yeah. I'll establish a measurement. I will clamp on and I will disconnect the grid and then I will reconnect it. Let's see if there's a good place to clamp. He probably was decent clamp here. And I'm just on 1 string. We could go on either one. We've proven that both of them are the same. So
329.4.
I'm now disconnecting the grid. Grid's off. Grids off mean no power coming out of the inverter, meaning no power. The inverter is not calling for any power, so those strings are not having to produce any work. If this inverter was working, I connect back in this power. The inverter will see the grid, it will decide yes, and then it will eventually draw from the panels. If it drew from the panels for even as much as a second, we would see a drop in that voltage. We would see that voltage, say, dip if there was a problem with the panels. I mean, we have put back in the grid disconnect, and we're flashing green as it is initializing.
Let's just get a picture of that.
Flick engines are happening. It's got a good voltage, a good frequency, and it's gone solid. Green solid. Serial number, it probably tell us inverter OK in a few seconds. It tells us that it put out 0 kilowatts today, etc. etc. 5 megawatts, 4.9 megawatts, inverter OK. Sorry, not megawatts, mega ohms in terms of insulation. Not bad. There's 5 million of them. Inverter OK. At no point in time did we get any dip on the voltage, which usually we'll check there right now. If we had a problem with the panels, that voltage would collapse under load. The voltage has not collapsed, it hasn't altered, it hasn't done anything. You know, all evidence is that you have an inverter that needs to be looked at a little more